back of the practice A for 5-6. Before we go any further, I want to look at this number 3 again because you can't use the hinge theorem on this. We can still make a determination on which angle is bigger though. So I redrew this pair of triangles since they're both right triangles and they have one pair of congruent sides. You can put this smaller triangle directly inside this triangle. So what happens is this angle 1 is just this small angle and this angle 2 is the bigger of the two angles. Angle 1 fits completely inside of angle 2. Angle 2 is definitely a bigger angle here, but you don't know it because of the hinge theorem. You can't apply the hinge theorem in that particular case, which is why I said what I said on the last video. For this next section, you have a huge diagram here. You want to match the conclusion on the right with the given information. Explain your reasoning. So for number 10, let's say that segment AB is the same length as segment BC. Also, the measure of angle 1 is bigger than the measure of angle 2. That's how you read that. Well, we're focusing on just this triangle and this triangle since we have two pairs of congruent sides. We can use our hinge theorem. If this angle is bigger than this angle, then we know that this side, segment AE, is bigger than this side, segment EC. So this guy goes there. Number 11. They're going to tell you that segment AD and segment CD have the same length. So I'll mark those over here. I'm careful to use 3 marks since I already used 1 and 2 over here. Also, the distance from A to E is bigger than the distance from E to C. So we can use our hinge theorem because we have two pairs of congruent sides. If this segment AE is bigger than this segment EC, then the angle across from it, angle 7, is bigger than angle 8. Number 12. We know that the distance from B to E is equal to the distance from E to D. Well, they're telling you that's equal. Interesting. Okay, so I'm just going to put 4 slash marks there since these are both the same. Angle 9 is smaller than angle 10 is what they're telling you. So you have this segment congruent to itself, so we're looking at these two triangles now. If angle 9 is smaller than angle 10, then this segment AB is smaller than segment AD. That's what they tell you there. This last one is obviously going to go with this one. Let's just make sure it makes sense though. A to B equals B to C. So we got that. A to D is equal to C to D. So we got that. What do we know? Well, we got two pairs of congruent segments. Angle 3 and angle 4 together are going to equal angle 5 and angle 6 together because this isn't even a triangle here. Right, so these two angles together are going to be the same as these two angles. Can we say that? I'm not seeing it. I don't know that you can make that assumption, to be honest with you, because these aren't even triangles. Okay, so obviously this one is matched up with this one, but I don't know that I agree with that. In fact, I don't think you can make that statement at all. Okay, so that's always a good situation to look at. Even though you know these two are the last ones, I'm very confident that all of these other ones are correct. You can't make this assumption. We don't have triangles here. I can draw a segment like this. That would be this guy up here. And then I can draw the same thing over here where those are congruent. Now I did this on purpose. Notice how this angle is clearly obtuse and this angle is not obtuse, or if it's definitely smaller than this angle, right? Having two pairs of congruent sides doesn't prove anything about the angle in between them. So that really makes no sense to me.